All right, today we're going to put on our detective hats and solve a little scientific mystery. The case? Figuring out the main goal of something called a cohort study. Now, I know that sounds super technical, but trust me, we're going to break it down into a puzzle that's actually pretty fascinating.
So here it is, our central question. What is the #1 job of a cohort study? We've got 5 possibilities here, but only one of them is the real primary goal. The rest? They're just clever decoys, designed to throw us off the scent. Have a look, see if you can guess which one it is.
But instead of just guessing, let's do this properly. We're going to treat each of these options like a suspect in a lineup. We'll check their alibis, we'll look at the evidence, and we'll eliminate them one by one until only the truth is left standing. Let the investigation begin.
Okay, our first huge clue comes down to one single word: time. See, a cohort study is like watching a movie. You follow a group of people forward, you see how their story plays out over years, even decades. That's totally different from a cross-sectional study, which is more like taking a single snapshot, a picture of one moment. Getting this difference is the key to cracking this whole case.
And boom, right away, that one clue helps us eliminate our first suspect. Option E, studying a disease at a single point in time, well, that's literally the definition of that snapshot, the cross-sectional study. So based on our first piece of evidence, suspect E is out of here.
And you know what? The exact same logic knocks out option C, to study the frequency of a disease. That's another job for the snapshot approach. Think about it, like a survey asking, how many people in this town have the flu right now? It's all about a single moment. So we can confidently cross C off our list too. It's getting smaller.
So what about suspect A, looking at the effects of an intervention? This one is a little trickier. A cohort study can be used to see what happens after, say, a group takes a new medicine. But that's not its only gig. I mean, tons of the most famous cohort studies are just observational. The scientists just sit back and watch what happens naturally, with no intervention at all. The goal is much, much broader. So A can't be our primary culprit.
And that leaves us with suspect D, connecting environmental factors to genetics. Again, this is definitely something that can be looked at inside a cohort study. It's super important stuff. But it's not the fundamental reason for this type of study to exist. It's a piece of the puzzle for sure, but it's not the whole picture. So we've got to rule out D as the primary goal.
So, after all that, after carefully investigating our lineup and eliminating all the other suspects, we are left with just one. The real reason scientists go through the massive, often decades-long effort of tracking thousands and thousands of people is, it's B, to establish cause and effect relationships. This is it. This is the absolute heart of a cohort study. Did being exposed to this thing cause that illness? Does this lifestyle choice actually lead to that outcome? These are the huge questions that cohort studies are built to answer.
And if you look at the official definition, it backs us up completely. It's a method that follows people over time to see how a specific exposure, like, say, smoking, affects their risk of a future outcome, like lung cancer. The whole thing is designed to connect a cause to an effect.
And here's basically how it works in the real world. First, you identify your groups. A cohort of people exposed to something, like smokers, and a cohort that isn't. Then, you just follow both groups for a really long time. And finally, you analyze the results to see if there's a real difference in the outcomes. See, the whole process is built to find that cause and effect link.
So the bottom line is this: cohort studies are the ultimate tool for being a scientific detective. They help us move past simple correlation, the fact that two things are just happening around the same time, and get us way closer to proving causation, the fact that one thing actually makes the other thing happen.
And believe me, this isn't just some boring academic exercise. The discoveries from these epic studies are literally the engine of medical discovery. The public health policies that keep our air clean, the advice your doctor gives you about what to eat. So much of that is built on the hard-won evidence from cohort studies.
Which kind of leaves us with a really interesting question for the future, right? We've done these massive, decades-long studies on things like smoking and nutrition. But what about all our modern exposures? Things like constant smartphone use, or all these new plant-based diets, or even working from home all the time. What cause and effect do we really need to understand next? What do you think should be the subject of the next great generation-spanning cohort study?